Hello. Getting things set up here. I believe I just posted your quizzes for science. So that's a thing now. Again, keep working on science. Your due date for science, we're looking at the end of the month. So get science done by the 30th. If you need more time, just let me know. I will be flexible with time due to the strange happenings in the world right now. So, right, so if you can't get in by 4:30, send me an email and we'll discuss each case individually, what to do. But your quizzes should be unlocked. I still have to give you Punnett square work, and I'm trying my hardest to find the best way to do that. I might end up live streaming for science Punnett squares one day. They are not hard. It's just a lot of terminology. So I might post a live stream for that. Today in math, we are looking at your review. Again, you had 2 days to do it. Today is your second day to do it. It is page something 392. 392, and it is just review from what we did last week and the week before. So if you do have questions on it, today's a great day to ask. I can do some more examples, things like that, but I mean, you're just finishing that up for today. Tomorrow, we're going to look at some graphing. So math tomorrow. We're going to do some graphing. And if you tune into the live stream, I will do that with you and walk you through it all. It's not difficult, but it's just something new that you probably haven't done in a while or you haven't done a lot of. And then math on Friday, you have a test on that kind of stuff, which really is not that bad. Just watch inequality signs and watch your inverse operations and combining like terms. So if there's any questions on things, I will hang on for a bit, but I mean, you're working on this page. I don't know if anyone's really screwing anything up on it yet. I haven't looked at it yet from yesterday. Only 2 people have turned it in, so. So yeah, if you have questions, how do you do 21? Yeah, I can do 21. Just give me a second here. 21. What does 21 even say? 21 is a word problem. Great. I'm going to paraphrase the word problem, write down the important information. You can follow along in your book. But a moving truck leaves the house traveling at a steady rate of 40 miles per hour. So your truck is going 40 miles per hour, which doesn't make any sense, but that's what it is. The family leaves the house 1 hour later. Following the same route, they travel at a steady rate of 60 miles per hour. So this is your truck, this is your family. At 60 miles per hour. This is like that plane problem that we were struggling with the other day. How long will it take the moving truck? After the moving truck leaves, will the car catch up to the truck? So we want to know when 40 miles times however much time is going to be there. T is going to equal your hours, I guess. I could write H for hours. Is going to be equal to, what is it? 60 times however many hours, but minus 1 hour, because you're traveling 1 hour less. Does that make sense? I guess I should have used H. I don't know why I'm thinking T for time. But this here is your equation. Again, you want the truck and the family to be equal to itself. So you're going to take the 40 miles per hour times however many miles it's going. So it's going to be whatever that is, 40 times however many hours you go, that's how far it's going to be, right? If it goes 40 miles in 1 hour, it's 40 miles away. 40 miles times 2 would be 80, so 2 hours will be 80 miles away, and it just scales up. The same thing's going to happen with your car. However, you're going 60 miles per hour, but you're 1 hour behind, so you got to take off 1 hour from it for one it to be equal. With that, you can just manipulate this to solve for your time. You want to get your hours together, so what I'm going to do is distribute first. To get rid of this parenthesis, I'm going to distribute 60 and 1, so this is going to equal 40 times 8. I'm going to leave off the parentheses here. 40h is equal to 60h minus 60. Don't lose your sign in that, and don't forget your variable as well. That is an h. Right? Then you're going to combine your h's, get your h's together. Again, you can move the 60h over here, or you can move the 40h over here. I'm going to move the 40h over, so I'm going to subtract 40h from this side. That's going to cancel and leave me 0. If I do it on that side, I got to do it on this side. So I'm going to subtract 40h on this side, and that's going to equal 60h minus 40h is going to give me 20h. And then I can't subtract from the 60, so I'm just going to tack on the negative 60. And then I'm going to solve for h using your normal algebra still. I'm going to add 60 to this side because it's negative 60, so add 60 to this side. And I get 60 equals 20h. Again, this is going to cancel with this. Move that over. I'm sorry, there's a 20 here. And then I'm going to divide this by 20. Divide this by 20. 60 divided by 20 gives you 3. This will cancel to be h, so it'll be 3 hours. And we can check that just by doing some, just kind of like doing some reasoning here. 40 miles per hour for 3 hours is going to be 40 times 3, so they're going to be 120 miles away. And hopefully this will be the same, so you have 60 times, well, really it's 2 hours because we're leaving an hour behind, so 60 times 2 would also be the 120 miles. And that's where you can see they're at the same spot. So that would be 21. algebraically. If you want to do it, you could also do that scaling. I can show you scaling that too, which is probably a useful skill to know too, right? You could just set up a table and be like 1 hour. So you have hours on top. You have the truck here. You have the family here. So I wanted hours here, right? In 1 hour, the truck is 40 miles away. The family is 0 miles away because it didn't leave yet. After 2 hours, the truck is 80 miles away. The family is 60 miles away because it goes 60 miles an hour. In 3 hours, the truck will be another 40 miles away, which gives you that 120. The family will be another 60 miles away, which gives you that 120. So there's your answer there. That's probably the way most people would end up doing that problem, just because it's really easy to scale it and the numbers are nice. But the formula will work if you change numbers around and stuff there too. So that's 21. Two different ways to do that. Any other questions on things? Jack is also asking for 21. I just did 21. So Luke and Jack, hopefully you're good on those two, on that one. And again, you're just working on that review. This is your chance to ask questions, so please make sure you're asking questions if you have them. If you are unsure of anything that you did, if you think, hey, this problem's wrong, ask. Math makes sense, so if your answer makes sense to you, then it's probably right. All right, 31. 31 says another word problem. Insurance salesman earns a salary of 121. So we're gonna, again, I'm not gonna write the whole problem. I'm just gonna summarize what's going on here. We have a salary of 1,200 per month. Each month plus a commission of 3%. So he earns a commission of 3% of sales. How much must the salesperson sell to have a monthly income of at least 1,500? So we want to know at least $1,500. So just so you know the terminology here, salary is he's getting paid no matter what he does, just for having the job and doing his job. Commission, for everything he sells, he gets 3% on. And this is kind of a strange problem because normally a salesperson will sell multiple things, and depending on how much each one sells, that 3% is going to be different. But I guess we're assuming that each object costs the same, so to speak. So the 3% is going to be based off of whatever he's selling. So that 3% is going to be a constant number. It's always going to be 3%. So you want to know when 1,500, and it has to be at least. So it has to be equal to or greater than, would be least. So this has to be more or the same as whatever he's making, and he's going to make 100 or 1,000, $1,200 just for, doing stuff, and that's going to be plus 3% of whatever he sells. So in that case, it's going to be 0.03 because we don't use actual percentages for things. We want to turn everything into decimals. So we're going to turn that into a decimal for that. And then we're going to multiply that by whatever he sells. So times, that's a bad variable to use, times his selling point. We're just going to say x equals how much he sells. So he's going to sell so much, get 3% of whatever he sells, plus the 100 or $1,200, and that has to be, I'm sorry, this has to be greater than or equal to 150. He wants to make at least $100 or $1,500, so it has to be set up like that. In this case, you're just going to solve for x. Yeah, nothing fancy really going on with that equation. We're going to subtract the 1,200 from both sides. Get rid of his constant rate first. You'll note that I'm not multiplying or dividing by a negative number, so my inequality symbol stays the same. And this is what? 300 has to be 0.03 times x, divide by 0.03, divide by 0.03. This is going to cancel. Leaves you with x has to be greater than, again, this is not a negative number, so this number is not negative. So we're not going to change our sign at all. 300 divided by 0.03 is, I'm cheating. What was that? 300 divided by 0.03. Yeah, it gives you that 10,000. So he has to sell $10,000 worth of whatever he sells. So, I mean, if that's a house, that's pretty easy to do. Just sell one house a month and he makes more than that. But yeah, there you go. And then Luke is asking for 22. Again, Jason, if you still don't get it, let me know. But I'm moving on to 22 with Luke here. You're killing me with the word problems. The Jaspers collect nickels, dimes, quarters in a jar. When they count the change in the jar, there is twice as many nickels as there are quarters. Okay, so we need nickels, dimes, and quarters. I'm just defining variables. When they count the change in the jar, there are twice as many nickels as there are quarters. So twice as many nickels as quarters. If you can read my writing. There is $15, $30 in dimes and $74 in all. Okay, so first thing I'm going to do is I define my variables. So N is going to represent nickels, D is going to represent dimes, and Q is going to represent quarters. There's twice as many nickels as quarters, so instead of writing that, I can put that into an equation. Twice as many nickels, so 2 times N as quarters, has to equal quarters. Right, so your nickels times 2 gives you the number of quarters you have. We know that there's that many dimes, that many dollars in dimes. You can actually solve that out if you wanted to separately. Right, if there's, right, you know, a dime, just, okay, things that you need to know. You know, a quarter equals $0.25. You know, a dime equals 0.10 cents, and you know that a nickel equals 0.05 cents. So it's implying that you know that, and I'm hoping you do. So I guess that's one of these is equal to each of those. You know that dimes have to equal 1530. So you know right away that using this right here, your number of dimes has to equal, actually your number of dimes times 0.110 has to equal 15.30. So you can go ahead and figure out how many dimes you have right there just because of this. And again, that's just, divide this by 10 cents. And that tells you how many dimes there make up for it. So go ahead and do that and just get that answer, 0.10 divided by 0.10. So the number of dimes we're going to have is we're going to solve for D here. 15 point. That's just going to move your decimal point 2 places. I don't know why I'm doing this on a calculator. That gives you 153 dimes. 153 dimes. So you know your dimes are going to equal 153 because of this statement. You know that everything has to equal $74 because of this statement. So I know that my dimes plus the number of quarters I have times however much a quarter is worth plus my nickels times however much a nickel is worth. And technically you have dimes times that too, but we already know what D equals, so we can just replace that with 135. Has to equal 74. I'm going to get rid of my dime work here. That's getting in the way. Has to equal 74. So I'm just reasoning through things to get the equation out of it. I know this is kind of a lot of information going on here. But again, just to wrap things up, I defined variables for things, kind of answered what this was saying in an equation, kind of made this into an equation and solved for how many dimes I had because I needed that information. And then over here, I made this into an equation here. It's just counting them up. So however many quarters I have times how much a quarter is worth, plus how many nickels I have times how much a nickel is worth, times how much money in dimes I have, how many dimes I have. Right? Then that's going to tell me. Actually, I don't think I need to know that. I need to use the money. So I'm going to use, you didn't need to figure out how many dimes you had. No one cares how many dimes you have. Dimes are represented by the 1530. Sorry about that. I think. Let me reread the problem. Yeah, it's just asking for how many quarters there are. I don't know how many quarters. I don't care how many dimes there are. I just need to know how much the dimes are worth. The dimes are worth 1530. It's not asking for how many dimes there are. Sorry, I was going to figure out how many nickels, dimes, and quarters there are. But anyways, it's asking for the 1530. So you can go ahead and solve for Q, actually, if you note. And you will get more practice doing this stuff next year, at least how I'm doing it, because it's a system of equations. But here, you see how we have a Q here, and we have a Q over here. I know that Q equals 2n, so instead of writing Q here, I can write 2n. And that's what I'm going to do. I'm just going to substitute this in for that. So 1530 plus, and then Q is 2n, so 2n times 0.25 plus n times 0.05 equals 74. My face isn't in the way, is it? No, I have plenty of room. Alright. So here you get your variables together. You can solve this. So I'll go ahead and solve this, and you can, well, that's, I'm going to rewrite that so it looks nicer. And you get 1530 plus 2 times 0.25, just double that, is 0.5n plus 0.05n. If you add your n's together, you get 1530 plus 0.55n equals 74. Solve for n. Subtract 1530, subtract 1530. Over here, this will cancel with this, leave you 0.55, and you can still see this, right? Yeah, you can still see that. Over here, you have 74 minus your 1530 gives you 58.7. And then you just divide each side by 0.55. divide by 0.55. This leaves you with n over there. This leaves you with 106.73-ish, hopefully. Which doesn't make much sense to me. I probably made a mistake somewhere. You're saying 2 times 0.75, or might this is 25. You're still saying that. I'm not sure what we're talking about here. We got 2n. Yeah, I'm going to start this over because that number's not making sense to me. Let me double check if I read everything right and copied things down right. Oh, that's one reason. This is 7480. That might change everything. So it is 74.8 minus, what is that? 15.3 gives me that side's going to stay the same. Gives me 59.5. I divide that by 0.55 should make more sense because it's actually not really. 0.55. Yeah, I'm going to start this over. Let me see if I can figure it out. Oh, I'm reading that wrong. Twice as many nickels as there are quarters means different. That's where I'm screwing up. Twice as many nickels as there are quarters, meaning that you take your 2 times the number of quarters you have should equal the number of nickels you have. That's what that actually means. Twice as many nickels as there are quarters. Yeah, because there should be more nickels than quarters. Right? I just read that wrong. That was my interpretation of that. That's my reading skills and why I'm not a reading teacher. But yeah, so this makes more sense then. At least it should. So you're going to get 1530 because that's how much dimes are worth, plus how much a nickel is worth, which is 0.05, n times, is that right? Yeah, how much a nickel is worth plus how much a quarter is worth, which is 0.25 Q, and then you're going to substitute in for n. So then you get 1530 plus 0.052 Q plus 0.25 Q. I'm using capitals, I should use capitals. And this is going to equal your 7480, and this is going to equal your 7480. And when you combine like terms here, you get 15.3 plus, and then 0.25 times 2 gives you 10, and then you can, well, I guess I'll do it in different steps. 0.10 Q plus 0.23Q equals 15.30 plus, then again combining these terms gives me 0.35 Q equals 74.80. Then you can do your algebra, subtract 15.3, I guess we'll keep the 0 minus 15.30. This gives you 0.35 Q is equal to 74.80 minus 15.3 gives you 59.5. Divide that by 0.35, divide this by 0.35. Q gives you 1.7 still. We're going to make that mistake. Because I forgot a decimal point. It gives you 170. In that case, your quarters are worth 107. No, that's how many quarters you have. Yeah, that is your answer. Because Q equals quarters, not the worth of quarters. 1Q equals this. So Q equals your worth of quarters. I hope that helped you out. Next year you'll find easier ways to do these problems. But it is a system of equations here. Jack asked for the answer to 31. 31 is anything greater than $10,000 or equal to. Remember that. Any other questions about it? I don't think I have word problems on the test, to be honest. I think actually there's 2 word problems, one for simple interest and one for compound interest. So I actually give you the formula to solve that. Any other questions? If not, I'm going to get off. Email me if you have a question. I'll work on it. But that's what we got. I'm going to end it there. So do that. Be working on your science. I unlocked quizzes for science. Your assignment sheet should have been posted a while ago, but I think I double-checked that. I'm not sure if that was posted. You are going to have a Punnett square work to do for science, and I'm probably going to have a live stream to do some questions.